Okay, we are now going to go over homework 2 for MGQ 201. So the first thing that I'm going to do is actually set up an Excel workbook. And this is going to be a really good idea for you, just so that you have the template for your quizzes and your exams. As you know, you're allowed to use Excel, and having a nice template for these assessments, you can build those based on these homework. Okay, so let's look at the first part of the chapter 2 homework. Using the 2 to the kth has to be greater than or equal to n rule. Determine the number of classes needed for the following data sizes. So these different data sets, we've got an n of 50, 200, 1,000, and 3,000. So this is our n here. And in order to determine how many classes we need, we'll also need to determine what k is going to be equal to. So k, let's just start with 2 and go up from there. Let's take it up to 15. Okay, so in order to figure out what 2 to raise to this k is going to be, I'll put equals to, raise it, caret, and then reference that value of k. Now, because I have referenced this relatively, what I can end up doing is pulling this down, and what that will do is give me what 2 raised to the power of each of the values of k is equal to. So then what I would have to do is say, well, which one of these values of k is going to give me a value here that exceeds 50, 200, 1,000, and 3,000. So in this case, where k is equal to 6, as you can see here, in this case I have to find a value of k that exceeds 200 here, 8, for 1,000 here, 10, and for 3,000 it would be a k value of 12. So I can just go in and put these directly into my stat lab. And the next value is going to be 8. Now your values are going to be different than mine, but the way in which you can set up your Excel file is exactly the same. Okay, so what I'm going to do here is actually put in 2, 2, 1, because that corresponds to the previous section. Okay, and as you can see here, 2, 2, 3. Okay, now let's construct a frequency distribution based on this discrete data. It's discrete because it doesn't have decimal places. In order to get the data into Excel, let's click on this, copy it to the clipboard, cut it, paste it. I mean, you can copy it right into Excel. What that'll end up doing though is it'll open up a new Excel file, and just copy it and put it into this folder. If you want to, or this workbook, excuse me. If you want to just copy and paste it into the workbook that you're creating for yourself, I think that's going to be easier. You can use StatCrunch, but you should also learn Excel. Okay, so here what we're trying to do, it's telling me the data values 1, 2, 3, 4, and 5. And what I'm trying to determine is how many 1s, how many 2s, how many 3s, how many 4s, how many 5s are in this array. So if I just put in those values here, what I can end up doing is, again with the frequency distribution, I'm going to create what's called an array formula, where I'm gonna bin all of the values of 1 here. So I'm gonna ask Excel to summarize how many times 1 appears, 2 appears, 3 appears, 4 appears, 5 appears, and I can do that all at once. First thing I have to do is select all of the adjacent cells next to the bin labels. So it doesn't work if I do this, it doesn't work if I do this, or then drag it down. You have to select all of them. Then equals frequency. The data array that I'm interested in summarizing is from A1 to A24, and the bins array is from C1 to C5. I could have put that 1, 2, 3, 4, and 5 bin label in any cells that were, you know, adjacent to one another. But I just chose C1 through C5. Let's close the parentheses and resist the temptation to just hit enter. In order to get an array function to work properly, you have to select Shift Control Enter, and that's on a regular Dell desktop computer. It may be slightly different dependent on whether you have a Mac or if you have a HP. So just Google if you are having trouble getting that Shift Control Enter to work and populate the array formula. Just Google, how do I get an array formula to work in Excel using my enter the type of computer that you have, Mac, whatever. And I can post some links there online that can put you in the right direction. Okay, so here we have it. We've got a frequency here, 6, 7, 6, 2, 3. Because your values are going to be different than mine, your frequency table is going to be different than mine as well. The relative frequency distribution, if you recall, I'm just going to shift this down here. These are the x values. This is the frequency of those x values. The relative frequency of those x values is simply this frequency divided by the sum of the frequencies. So the sum of the frequencies is going to be 24. So what I can end up doing here is referencing this relatively at the top and this absolutely at the bottom as a denominator, and then drag this down. So let's continue here, and it's telling me to round to the nearest thousandth as needed. 0.25, 0.292. Oops. 0.25, 8. 3, sorry. And 0.125. Nice job. Rounding here. And the cumulative relative frequency, if you recall, cumulative relative frequency is simply going to be, in this first value, the same as the relative frequency. The second one is going to be this relative frequency plus all preceding relative frequencies, which is actually the preceding cumulative frequency. After I've gotten this, I can drag it down, and I can just double check that my last cumulative frequency for the highest bin is 1, because 100% of the values are going to fall underneath that bin label. 0.792 and 0.875 and 1. Let's check the answer here. Great. Okay, so that's what we've got for our exercise 2.2.3. 2.2.7. A major airline records the number of no-shows for the last 70 flights from one city to another. So a no-show is a passenger who purchases a ticket but doesn't arrive at the gate, at least in time for the departure. So we're going to construct a frequency distribution for this data. I clicked on this frequency table, and here what I can do again is copy it to the clipboard, Control C, and put it into my Excel workbook, close these out. Again, my bin labels, so I could go ahead and put them wherever I'd like. Again, selecting all of those adjacent ones before putting in my frequency command. And the bins array, close the parentheses, Shift Control Enter is giving me 15 no-shows, 12 1 no-shows, 15 2 no-shows, 14 3 no-shows, and 14 4 no-shows. And that's per, it looks like flight, or airline, yeah. So for the last 70 flights on one flight, on 15 flights, it was full, there was no-shows. On 12 of them, one person no-showed, so on and so forth. Okay, just so we keep clear on what these are, this is the frequency of those x's. Let's set up our relative frequency and our cumulative relative frequency. Okay, so let's grab the sum here. I'm just going to do this all in one step. Equals, again, relative divided by the absolute reference. It's good to get into that practice, because then you're more efficient. And here, same as the first relative reference. Here, this relative reference for this class plus all preceding classes. And once I have that set up properly for this cell, I can just drag it down, make sure that that last one is equal to 1. Okay, so let's go ahead and copy this into oops, mistake. I did that on purpose, so I show you. Catch your mistakes. I also would not recommend copy and pasting into my stat lab. I just have had so many students that have had issues with that. So just take the time and put it in manually. It'll get you in good practice for the quizzes and exams too. 2 1 4, and all I'm doing here is copying these right in from Excel. Okay, and we've got our cumulative relative frequency here. This is my last column here. So this first one is going to correspond directly with my first relative frequency. Here I've got my next cumulative, next, and finally 100% of the data equal to or below a value of 4. Okay, let's check our answer. Great. It looks like here they want us to construct a histogram, and for this they want us to look at the frequencies just to show you, give you a little preview for what this is gonna look like. All I did there is I selected the data really quickly. Here though, look, I guess the label is 1, 2, 3, 4, and 5. We know that's not the case, and actually what it's going to be is 0, 1, 2, 3, 4. We'll get more into this as we get more into graphing. But here we're just trying to sort of line up which of these looks the best. And it looks like if you just take a look at the axis here, this one, it looks like it exceeds 16, and nowhere does it do that in the graph here. So it looks like the best one is going to be C. That corresponds with this. So final check. Great. Okay. Now would be a good time to save our file. What I would do here, I'm going to do homework 2. HW2. Alright, let's grab a new tab. Again, this is what we call a worksheet. This is the entire thing is called a workbook. And we've got a bunch of different temperatures here, it looks like. And essentially what we're going to have to do is take all these temperatures and please, please, please don't sort them and then guess and go through and do this manually. Use the frequency function. Use the frequency function. Third time. Use the frequency function. Okay, copy and paste this into Excel. And here, the first thing we're going to have to do is if we go back into our tab with the K values, we're going to have to see, based on these 125 values, how many classes, or K, what's the value of K that's going to be equal to or less than that. Or I'm sorry, equal, it has to be greater than 125. Because again, I have 125 observations. So which value of K is going to meet that expectation is going to be 7. So the first thing I need to do when I'm deciding between A or B is determine which one has the correct number of classes. In this case, I know the correct number of classes is going to be 7. So A has 1, 2, 3, 4, 5, 6, 7, 8 classes, whereas B has 1, 2, 3, 4, 5, 6, 7. We know it's going to be B, and that's again just based on the 2 to the kth has to be greater than or equal to n rule. That gives me a hint as to what the bin labels need to be. Okay, so I'm going to go back into my sheet 4 where I've pasted the data for this problem, and I see that it's telling me what the values are for the frequency distribution I'm going to create. So less than 72, and these are continuous data, so they are not discrete. That means that we have to, if we put 72 here, it's not going to capture all the values that have a decimal place after it. So less than 72 is similar to saying 71.99. I'm going to take it out 1 extra decimal place. So instead of 0.9, I just put 0.99. And then less than 74, 73.99. Okay, what I'm going to do here is drag this down until we get to 83.99, and that corresponds to less than 84. Now, when I'm using the frequency function for continuous data, I really only need to put in the upper bound of the bin. But you could, you know, if we're labeling it correctly, you could say 70, and this is 72, so on and so forth, okay? But this is the lower bound, and this is the upper bound. The only part that I need to tell Excel in order to execute this command properly is this upper bound. Okay, so similar to as I showed you before, in order to get this frequency function to work as an array, select all adjacent bins equal to frequency of these 125 values for the bin array, and this bins array is again going to be only the upper bound. So what it's actually saying is that how many of these values in A1 to A125 fall below 71.99 all the way to the preceding upper bound. In this first class, in this first bin, if you will, that's going to go all the way down to 0 to the lowest value, okay? But in this case, in the 73.99, it's going to say how many fall at or below this, all the way down to the preceding class. So the values that fall in between those, okay? Let's close that bin array. I'm sorry, the frequency function. Shift Control Enter, and we've got a nice frequency distribution here. So this is the frequency with which those X values appear, and we can just go ahead and put those in. I was being slick, being quick. Better to be slow and steady. 15, 6, and 1. Let's check that. All right, let's go ahead and put these in. 1, 20, 43, 39, 15, 6, and 1. Check that answer. Good job. Now the relative frequency, all I'm doing now is the same thing as I have been doing before. I know I can just divide this by 125, but just to be on the safe side, this is actually a good thing to practice. Making sure that the sum of the frequencies adds up to the number of observations. So, I'll say that again. Sum of frequencies should add up to the number of observations. Okay, so for each of these, let's take this and divide it by that. That will be down, and I already know that they're going to ask me to do this, so might as well just do it while I'm here. Equals this cumulative, and this is equal to this plus this. Okay, let's bring it down. This is going to be equal to 1. Perfect. Perfectly here. I actually just had to edit something out because I started putting them right into here. If you take a look, the number of classes jumps. So here it's 7, and I thought it would just be 7 under here, so I just started mindlessly putting it in. But actually, now the number of classes for 7 is over here. So it's, instead of, they make it, you have to do a little extra work. Okay, so as I was saying, this, sometimes it's this little stuff of having to copy and paste that will get you. So just take your time. Check this answer. Great. And the cumulative frequencies. So again, less than 72. Here's the appropriate one. Here, 0.168, 0.512, 0.824, 0.944, 0.992, and 1. Let's check this answer. What? Fantastic. And histogram for the frequencies. Let's check this out. Just quickly. This is what it's looking like. I'm gonna go ahead and say 1. Let's see. The highest value is a little over 40, whereas the other ones, yep. Great. Oh, what percentage of the days was the ocean temperature less than 74 degrees? Okay, so for this one, we're going to be using the cumulative relative frequency. So for what percentage of the days was the ocean temperature less than 74 degrees? Well, here the upper bound of 73.99 is the same as saying less than 74 degrees. And this was a cumulative relative frequency of 0.168. So that's the same as saying 16.8% of the days. Excellent. Next question. Okay, we're going to go through this. What was that last one? 2.210. Okay, just want to label this properly. 2.2. Okay, 2.3. I'm going to make a different video for the latter part of chapter 2. So this will be the last for this first part of the chapter 2 homework. Let's grab this data, and here we've got freshmen, sophomore, junior, seniors to denote that are denoted by FR, SO, JR, and SR. Okay, so copy to the clipboard. Let's grab it, put it in. This is what type of data? Well, let's think about it. It's definitely qualitative. It doesn't have numbers associated with it, but it can be ranked. So we could consider it to be ordinal. Very good. Okay, let's put our values in here. Freshman, sophomore, junior, and senior. And here we can't use the frequency function. We can only use the frequency function if we have quantitative data. That quantitative data can be either continuous or discrete. This is qualitative data, so we have to use a slightly different function, and it's just going to be a countif function. So we can still use it as an array. So equals count if, and this particular range is going to be between A2 and A41, just because I had inserted a header there. And the criteria, I'm going to select this bin array, close it, and Control-Shift-Enter. And these are the values. They're the numbers of the times that freshman, sophomore, junior, senior labels appear. So the frequency of those X values. Sorry. Yeah, these are the X values. So X values can be qualitative or quantitative. In this case, they're qualitative. Alright, so let's go in and put these in 13, 7, 8, and 12. Excuse me, check this answer. Relative frequencies, same thing that we're going to do here. Sum this up. Equals this relative, this absolute, drag it down, pop it in here, 0.325, 0.175, 0.2, 0.3. Don't mind that. Forgot to turn off my email. Okay. Construct a vertical bar chart here. And this they want for a relative frequency. So I've already got my data highlighted. And it's looking freshman, sophomore, junior, senior. And again, the way that I would change those axes is by going into select data and selecting the appropriate label here. And changing the title, but we're not going to get into that right now. So it's looking like this. It's a little bit over 0.3. If you're ever in doubt, look at the axis and make sure that it's lined up appropriately. So it's looking like A again. Okay, that's going to wrap it up for the first part of the chapter 2 homework. What I would recommend doing is going through this video, going through it as I work through it in Excel. Save your work, because you'll be using it on your quiz and your exam. Okay, to be continued in a subsequent video for the rest of the chapter 2 homework.